Hey guys, this is the 5.5 homework, which is solving equations of exponentials and logarithms. So just diving right in for the first question, there's a couple. This one is a way that we can manipulate this one right here. They both have the same base, and so in terms of making both sides equivalent to each other, since they have the same base, I can just focus on the exponents. So 3x plus 5 equal to 1 minus x. Since the bases are already the same, I just need to solve the exponents. And so let's add x, just so this is now just a linear equation. So add x, and I get 4x plus 5 equal to 1. I'll subtract 5, so subtract 5. I get 4x is equal to negative 4. Divide by 4, and I get x is equal to negative 1. And you can always plug that in to see if that's what you get. Okay, now in this case you might think, well, the bases aren't the same, but you can manipulate this side right here in order for them to be the same. So while this is 5 to the x minus 3 power, I can write this as 5 squared to the x minus 5. And since I have a power to a power, I can multiply. So in other words, I can distribute that. So I get 5 to the x minus 3 equal to 5 to the 2x minus 10. And now that the bases are equivalent, I can set the exponents equal to each other. So x minus 3 equal to 2x minus 10. And now I can solve this linear equation. I'll subtract x, I get negative 3 is equal to x minus 10. I'll add 10 and add 10. And I get 7 is equal to x. So if I plug in 7 there, I get 4. If I plug in 7 here, I'll get 4 as well, because 5 squared, and yeah, so that checks out. Now in this case right here, 7 and 3 are not going to be able to, you can't manipulate those to have the same base, so we're going to use just operations. So how do I undo an operation of base 3? You have to use a logarithm of base 3 on both sides. So if I use a log of base 3 on both sides, so log base 3 of this term, log base 3 of this term right here, well, considering that I can use the power property and drop this down, this is just like the long way to do it. Typically I would just say those cancel, and they do, but if you use the properties, so x times by log base 3 of 3 equal to log base 3 of 7. So if we use our properties from 5.4, meaning I can move this to the front spot as the coefficient. That's one of the properties of logarithms. Now a log base 3 of 3 is equal to 1, so then I get x is equal to a log base 3 of 7. And that would be the exact answer to that. Okay, moving here, I have the exponential here. Now, I also have this being multiplied by 5. This 5 cannot multiply to this 7 because of the order of operations. Whatever x is, the operation of the exponent has to come before the operation of multiplication. So that when solving this equation, this needs to be isolated first. So I'm going to divide by 5 in order to isolate the exponential. So now I'll have 7 to the 5x equal to 12. 60 divided by 12 is 5, right? Yes, it is. Okay, now that the exponential is by itself, I can use a logarithm of base 7 on both sides. So then this becomes log base 7 of 5x equal to log base 7 of 12. That's going to cancel, so then I'll get 5x is equal to log base 7 of 12. And then I can divide by 5. I can't just divide the coefficient by 5. It's everything that's going to be divided by 5. So x will be equal to log base 7 of 12 divided by 5. For 3, so again, look at the exponential, so in this case, e to the 4x. That is what needs to be isolated. I am going to first subtract 9. So subtract 9, subtract 9. So 3e to the 4x will be equal to 6. And then I'll divide by 3 and divide by 3. So then I'll get e to the 4x is equal to 2. Now that the exponential is all by itself, I'm going to use a natural log on both sides. So I'll get natural log of e to the 4x equal to the natural log of 2. Those will cancel since the base of the natural log is e, and I'll get 4x is equal to the natural log of 2. Then I'll divide by 4, divide by 4, and x is equal to the natural log of 2 divided by 4. Okay, now moving on to the next page, this will be solving logarithms. Similarly with this one right here, for these two, we'll use a similar method as we did in this first couple ones up here, in the sense that, well, this is a natural log and this is a natural log, so they're the same base logarithm, and in that case, they're not really relevant, or they're easy to kind of ignore. Whenever it comes to solving, all I need to solve is to make sure that the inside of the logarithms are the same. So 4x minus 7 has to be equal to x plus 11. So I'll subtract x and subtract x. 3x minus 7 is equal to 11. I'll add 7 and add 7. And I'll get 3x is equal to 18. Divide by 3, divide by 3, and I get x is equal to 6. Okay, likewise in this case right here, this is log base 2 and log base 2. They share the same log base, so I just need to make sure that these are going to be match. So 3x minus 4 has to be equal to 5. I'll add 4 and add 4, and I'll get 3x is equal to 9. Divide both sides by 3, and I'll get x is equal to 3. For 8, okay, so I don't have logarithms on both sides, so now we're just going to use operations, inverse operations, in order to solve for x. Now, since the logarithm is all by itself, then in that case, what we're going to do is the operation of to exponentiate. So this is a base 2. In order to get to this logarithm, I have to exponentiate both sides with a base of 2. So this is 2, and this expression is the exponent. Same on this side. This is a base of 2. 5 is now the exponent to 2. Don't get this confused. This isn't 5 squared. This is 2 to the 5th. This isn't 5 times 2 or 2 times 5. This is 2 to the 5th power. Now, those are going to cancel, and I'm going to get 4x plus 8 equal to 2 to the 5th, which is equal to 32. So that's going to be 32 right there. And then I can solve this like a linear equation. Just subtract 8, just subtract 8. I get 4x is equal to 24. And then divide by 6, divide by 6. Divide by 6. What am I thinking? Divide by 4. Divide by 4, and I get x is equal to 6. Likewise, in this one right here, I have a log base 7 here. This is the only logarithm on this side, so in order to get rid of it, I'm going to give both sides of the equation as a base of 7, meaning I'm exponentiating both sides, and that's going to get rid of our logarithm. I'll get 4x plus 9 equal to 7 squared. Remember that that's 7 squared. That's going to be equal to 49. Then I'll subtract 9. I'll get 4x is equal to 40, and I'll divide by 4 and get x is equal to 10. Okay, and here I'll give this a base of 2, and I get x squared minus x minus 6 is equal to 4. Remember that that is 2 squared, which is equal to 4. Okay, now I don't have a linear equation like in all of these ones right here. I have a quadratic equation. So first thing I'm going to try to do is get everything onto one side, make one side 0, so x squared minus x minus 10 is equal to 0. And then I'm going to see if that's something that I can factor. So are there two values that will multiply to be negative 10 and add to be negative 9? I think that, oh no, add to be negative 9, negative 10, or no, sorry, add to be negative 1. I don't think so. I think that needs to, I think we need the quadratic formula for that, if I'm being honest with you. Yeah, we need the quadratic formula, so not factorable. So not factorable. So x is equal to negative b plus or minus the square root b squared minus 4 times by a times by c all over 2a. So a is equal to 1, b is equal to negative 1, and c is equal to negative 10. So I'll get x is equal to 1 plus or minus the square root of b squared, which will just be 1 squared, well, negative 1 squared, which will be 1. So 1 minus 4 times by a times by c all over 2 times by a. And that's going to be equal to 1 plus or minus the square root of 1. So that's going to be negative 10, and negative 4 times negative 10 is positive 40 over 2. So that's going to be equal to 1 plus or minus 41 divided by 2. So let me punch this into the calculator. So 1 plus the square root of 41 divided by 2, and I get that this is equal to 3.702 if I round, or I do 1 minus the square root of 41, divide that by 2, and I get negative 2.702. Now, probably need to check for extraneous solutions. So if I take this number right here and plug it in for x. So let me do that. I have my own calculator that I'm doing this in. So 3.702 squared minus 3.702 minus 6, and I get a positive number, so we're good. Whenever I plug this in, by the way, in my calculator, I get 4. So I get log base 2 of 4 equal to 2. And this is true because if I have 2 squared, that's going to equal 4. So that is true. And then let's try doing this other number right here. So I'm going to plug this number into that right there. Basically, I'm checking to make sure that this number becomes positive because you can't use a logarithm of a negative number. So Let's try this. We'll do that squared minus negative 2.0702, and then minus 6. And again, I'll get 4. So if I plug this in right here, I get 4, which will end up being 2. So checks out. Both of those solutions will work. Okay, for this one right here, now you can see that we have 2 logarithms. Now, what I can't do is use 2 and 2. So I can't just do 2, raise them with a base of 2 like I did on this one. This was only the case because there was only 1 logarithm. But I have 2 logarithms on this side. So instead of exponentiating, so if I exponentiate with a base of 2, that's not going to get rid of both logarithms. Instead, what I need to do is I need to condense these logarithms. So we have to do what we did in 5.4, which is condense. So first of all, we're going to condense. So because these are adding between them, x and x minus 2 are going to be multiplied by the properties. So I'll have a log base 2 of x squared minus 2x equal to 3. And now that I have 1 logarithm, now I can exponentiate. I don't know how I'm writing, I don't know why I'm trying to write this in steps. So for 2, this is to exponentiate. And so now I'll have x squared minus 2x equal to 2 to the third, which will be 8. And again, I have a quadratic, so let's go ahead and subtract 8 from both sides. So subtract 8 and subtract 8. And I'll get x squared minus 2x minus 8 equal to 0. Then here, let's see if this is factorable. So x equal to 0. What multiplies to be negative 8 and adds to be negative 2? I think that's going to come out to be x minus 4 and x plus 2. So my solutions will be x equals 4 and x equals negative 2. Now you need to make sure that these will work. So if I go back up to my original expression right here, so if I plug in 4, I get a positive number in my exponent. If I plug in 4 here, I get 2, so that checks out. But if I plug negative 2 right here, then I get log base 2 of negative 2, which does not exist. Also, if you plug in negative 2 here, we get log base 2 of negative 2 minus 2, which will likewise come out to be negative 4. So this is not a solution. That's extraneous. Okay, for 12, so again, we have 2 logarithms. What I'm going to do is condense. So then I'll get the natural log of x squared plus 3x equal to 4. And then I'm going to exponentiate with a base of e, since the natural log has a base of e. So then I'm going to be left with x squared plus 3x equal to e to the 4th. Now this might be scary, but that is just a constant. So I'm going to do the same thing I did in the other one. So x squared plus 3x, and then a minus e to the 4th equal to 0. So the only thing about this right here is that obviously this can't be factored, since e to the 4th is not a, it's a irrational number. So that means since it can't be factored, you have to use the quadratic formula. Now, if I use the quadratic formula, a will be equal to 1, b will be equal to 3, and c will be equal to negative e to the 4th, which is kind of weird trying to use that as c. In any case, if we use the quadratic formula, x is equal to negative 3 plus or minus the square root of b squared, which would become 9, minus 4 times by a times by c, all over 2a, which would just be that. Now this is the part that would be annoying, and I'm not going to expect you guys to, well, I mean, all you need to do is just plug this into a calculator, but that might be annoying, and you have to plug it in twice, because you have to plug in for plus and you have to plug in for minus. But if you leave it right here, I'll be okay. We're not, but also keep in mind that both of these solutions might not be a solution, since one might be extraneous, but as long as you get here, I'll be pretty happy, alright? We'll save using the quadratic formula for when we don't get constants like e to the 4th power, because that's just annoying to work with. But let's move on. So for 13, again, we have 2 logarithms, base 3, so I'm just going to end up multiplying these two together. So log base 3 of 9x squared equal to 2. I'm going to exponentiate with a base of 3. So I'll get 9x squared is equal to 3 squared, which would be 9. This is an easy quadratic for once. So divide by 9, I get x squared is equal to 1. Take the square root, and I get x is equal to plus or minus 1. Now just to check, if I plug in 1 or negative 1 right here, it's being squared, so that becomes positive if I use positive or negative 1, so both work. And then here, I'm going to condense these right here, meaning these are going to be multiplied. So then I'll get log base 3 of x squared minus 3x minus 9x plus 18 equal to 2. Log base 3 of x squared, these can be combined. So minus 12x plus 18 equal to 2. Exponentiate. So then I get x squared minus 12x plus 18, and that's going to be equal to 9. Subtract 9, subtract 9. I get x squared minus 12x plus 9 equal to 0. And then, are there two numbers that multiply to be 9 and add to be negative 12? I don't think so. So you have to use the quadratic formula. So a is equal to 1, b is equal to negative 12, c is equal to 9. So we'll get x is equal to 12 plus or minus the square root of 144, if we square that, minus 4 times by a, I'm not going to write it because a is 1, times by c, all over 2, plus or minus, okay, let's do 144 minus 4 times by 9, and I get the square root of 108 divided by 2. So let's do 12 plus the square root of 108 divided by 2. So I get x is equal to 11.196, and I get x, let's do 12 minus the square root of 108 divided by 2, and I get x is equal to, I get x is equal to 0.804. Let me double check these. Just checking my calculator to see that these will work. So log base 3, we'll do x minus 9. And then let me do this one right here. Oh, what the heck? That should be a 3 right there, by the way. Not an x. I hope so, anyways. I think I did something wrong here because my answers aren't coming out to be right. So let's review my steps right here. So I multiplied. That's what I did wrong here. That should be 27. Oh my gosh, that's gonna be 27, not 18. So that's gonna be 27. That means that this is gonna be 27, which means that that's gonna be 27. And then 27 minus 9 is going to turn out to be 18 instead. Which means this is going to turn out to be 18 right here. Which means that's going to be 18. Okay, let me redo these right here. So that's not going to be 108 right there. That's not going to be correct. So 144 minus 4 times by 18. Do the square root of that. So we do 12 plus the square root of 144 minus 4 times by 18. And divide that by 2. And I get x is equal to 10.243. And then if I do this right here, but I do subtraction, divide that by 2, and I get x is equal to 1.757. Now if I check, so if I'm pretty sure this works because I got really close. This was closer to my other one, but so if I plug that in right there, so this one's not going to work. I can already tell because if I plug this in right here or right here, I get a negative number. So that one's going to work right there. Okay, 4 more problems and we'll be done. So solve this inequality right here. So these are just inequalities, so we're going to do the same steps as before. So I'm going to do a log base 9 of 9 to the x, which is greater than, and then a log base 9 of 54. So then x is greater than log base 9 of 54. And then we can, well, let's go ahead and put this in our calculator. So we'll do that. So I get x is greater than 1.815. Okay, and in this one right here, we'll exponentiate with the base of e. So we'll get x is greater than or equal to e to the third. And e raised to the third power, so x is going to be greater than or equal to 20.086. In this case right here, I'm going to do a log base 3 of 3 to the 4x minus 5 is less than, and a log base 3 of 8. So then I'll get 4x minus 5 is less than log base 3 of 8. Let me go ahead and do log base 3 of 8 in my calculator. So log of 8 divided by log of 3. So I get 4x minus 5 is less than 1.893. Okay, and then I'm going to add 5. So then I get 4x is less than 6.893. And then divide by 4. And I'll get that x has to be less than 1.723. And that will be our final answer right there. Okay, and then here, let's get rid of this 6 right here. So let's go ahead and subtract 6. If there's no parentheses shown here, that means that this is not included. So parentheses are actually right there, if that helps. So negative 3 log base 5 is less than or equal to 3. Now in this next step right here, whoops, I forgot to write my x right there. So I'll divide by -3. Now if I divide by a negative number, that's going to flip. So I'll get a log base 5 of x is greater than or equal to -1. Then I'll exponentiate with a base of 5. I'll get x is greater than 5 to the -1, which means that x is greater than or equal to 1/5, and 1/5 is 0.2. So x has to be greater than or equal to 0.2. Okay, and that should do it for 5.5.